Okay, today we're going to talk about some mods for the Rudy and the Tin Man 3D printed robots I've done in the past. As you know, the earlier ones both ran on a single AA battery, which had its limitations. It was okay for Rudy, and by the time like the Tin Man and added even more lights in the eyes and everything else, it was kind of pushing it. The biggest mistake I made on Tin Man was deciding I wanted to paint it. I really wanted this hammer tone silver paint look, and of course the paint on the leg surfaces to the body surfaces adds so much friction that it really makes the toy not work well. So like with the Rudies, you're better off just paying the money and buying the color of PLA that you want in the first place. PLA on PLA is very low friction, works very well that way. So first thing I did on this version of the Tin Man, instead of a single AA battery, I'm going to go with two AAA batteries, which means I had to redesign the back piece to fit in a two AAA battery holder. This gives us a lot of advantages. First, you have 3 volts already, so that means your red LEDs you can light off the 3 volt without having to use a power inverter, just some current limiting resistors. In this case I wanted to see how low I could run the current and still have everything visible, so I went with like a 1K resistor on the 3 volt supply, and they're drawing 1 to 2 milliamps, very low. It also gives more voltage for the motor, so you can get a faster walking action if that's what you wanted. In this particular one I even experimented with changing the motor in the gearbox. This is all yellow on yellow, but this standard gearbox and this standard motor. This standard motor draws a lot of current, so I went ahead and took one of these gearboxes and cut that off and attached this more efficient. They sell them as solar motors, but basically there's more pole pieces and actual bronze oil-light bearing. There's actual carbon brushes. It's just a lot more efficient. The whole thing only draws like 34 milliamps or so running it. I just want to see how low I could get the current draw on the robot to be with all the added friction of the painted parts rubbing. If you're going to include the forward and reversing like I did before, then you still need to come up with a relay, unless you can design your own mechanical switch that'll fit down there. A snap action double pole double throw switch, kind of tough, but it could be done. Easier way is just to use a relay, and you can't really find them in the 3 volt range. This is a 5 volt double pole relay, double pole double throw relay, and which means I am still running a power inverter in order to get the 5 volts that I need just for the relay, so this isn't being taxed by running the LEDs or anything else. Functions you probably want to see, so you can see that's marching right along quite a bit faster. Still have the forward and reversing. In reverse it does draw a lot more current. You can still see the LEDs even though they're running at such a low current. Okay, so besides changing the back to hold the larger batteries, I changed a few other files as well. One, as you can see on the bottom of the feet, I have added a taper to the toes and also shortened them by about 2 millimeters. So if you had a sloppy fit, there's less chance that the toes are going to hang up on each other. More clearance, still plenty stable. So I made that change to the toes. Now on the arm linkage, and we'll get this up maybe where the camera can see what we're talking about. The arms link onto that smaller pin. This is the cam that's rotating, moves the leg on the big part. The small part is what's driven for the arms. Well, I had to make this piece, this whatever you want to call this part of the linkage that rides on the pin, short so it wouldn't bind up on the top of the legs on the original version. But the problem with that is when the pin is down in this very lowest possible setting, it is possible that if the arm gets manhandled, or if you're assembling the robot, you might get this part down below, or it might get forced down below, and then that's just going to jam everything up. The motor can only run so far one way, and the other way it's going to jam. So I went ahead and made these arms on this cam follower 2 millimeters longer, so they at least reach halfway through that pin, worst case. So that shouldn't really go anywhere. The problem with that is if you stay with the stock leg, when the leg comes all the way up, and that's why we're going to look at this side now, when the leg comes all the way up on its cam, you can see that follower would hit. So I had to redesign the leg to lower this inside part of the leg down 2 millimeters so that this part could be 2 millimeters longer. So if you have old files that you're working with, you want to make sure you keep the old arms with the old legs. And if you've got the new ones, the new files, I put them Thingiverse, I marked as new, the new legs and the new followers. And that just keeps this from becoming a possible thing that could be hard to assemble, or if someone manhandles the arm enough, they might actually, in this case, get on there and slip it past the post and then jam everything up. So I improved that. What else? Seems like there was something else. I also, let's strip this stuff out. I also thickened up this part that the motor sits in. Let me get the motor here. The cradle part, so that because this print's flat and it's going to be all full of supports, when you're yanking all the support material out, it was kind of easy to break anything that was thin, so I thickened those up. But when those got thicker, that meant that the cams that drive the legs could possibly rub and bind there. So I changed the cam width, added more space there so that it would clear, like so. So that's the biggest changes. More area for doing dual battery. Thicker support area here for strength. New legs that are a little bit lower here so that the new arm mechanics can work without binding. I think that's about it. I think that's about all I want to tell you. It's just a bad idea on this design to go painted, because if this part here gets painted and this part here gets painted, when the toy's put together, you can see how that painted part's going to rub on the inside there, and the painted part of this is going to rub on here, so you don't want to paint the back of the leg either. And it adds so much friction that the mechanics basically can't work very well, if at all. So PLA on PLA, very good bearing surface, very smooth. I would say just if you want a silver robot rather than trying to paint it, just get silver PLA and print it that way. I kind of wanted the hammer tone look, and you can't get that in a PLA. So I had to go back in and kind of file out the high points of the paint on all those areas to keep things loose. Did a lot of extra filing on that. Get everything loose and working. I think that's about it. I think I've upgraded all the files on Thingiverse for those new parts that are more reliable, and offered both options. Have the original body back option for the single, because this works just fine for the Rudy and that kind of stuff. But as soon as you start adding forward and reverse, or adding all the LEDs, why not go to a little bit higher voltage and make everything work better?